All right, so this is JavaScript therapy with generators, and why exactly that's the title will become clear in a bit. I am Jana Beck. I am J.E. Beck on most places on the internet, like GitHub, and a lot of Slack teams and stuff like that. But on Twitter, I'm iPancreas, so that's the place where I'm somebody else. And this slide deck is online at janabeck.com, JavaScript-therapy. So since the Wi-Fi is great, if you want to follow along, feel free to. And there are some interactive slides, so you may find that fun near the end. So this is what I used to do. And don't worry if you can't read it very closely, or if you just can't make sense of it. This is actually the meaning, or a proposal, a theory for the meaning of this little tiny two-letter ancient Greek word. And it's expressed here in something that some of you may recognize as lambda calculus. This is nothing unusual in modern generative semantics, which is something I used to do. Along with some collaborators, we theorized about the meaning of words and then published our theories in peer-reviewed journals. If this is still what I was doing, I probably wouldn't be talking to you today. What I do now is build applications, mostly data viz intensive applications and tools. And the tool sets that I use are D3, React, and Redux. That's like the main three things that I use a lot. So why am I telling you this? Well, I threw up that weird lambda calculus because those of you who did recognize it are probably the functional programming superfans in the room. And you probably won't be surprised that having this background in linguistics, I haven't found functional programming concepts difficult to pick up now that I'm working as a software engineer. That's been like one of the easier roads for me. But like 2015, I ran into something that was harder for me to pick up, and that was generator functions. And a big part of the reason it was hard is because generators are about concurrency, and that's not something that I had ever run into before in programming. JavaScript is single-threaded, as we'll talk about. And so this was just tough. And a little bit more context about when this happened and what the context for it was. So I said it was about late 2015, early 2016. I'd been working at this company, and I was leading a refactor of 2 React applications that they were greenfield React applications in late 2013, which was quite early for React. And at that time, Flux and later Redux weren't really being talked about as state management solutions. And even React Router may have existed, but it wasn't as widely adopted. And we had picked a different routing library that wasn't very well suited to the declarative style in React. So our application had this homegrown state management solution that had gotten messy and out of hand, and it had this really messy routing. So we decided to do this big refactor and added in Redux and React Router, actually, at the same time to simplify all this and kind of bring ourselves back up to speed with the rest of the environment at that time. But as you may kind of remember, at that time, or at least it feels like it to me, that's when all the ES6 stuff was really hitting. Like I remember the React docs were starting to use ES6 in the examples, and I was working at this tiny startup, and we hadn't really had a time to catch up with all that stuff. So at the time, I found it pretty frustrating. And when I was leading this refactor to put Redux in, we had to evaluate the tools that we'd need to use to handle asynchronous flows in Redux. And so at the time, that was a choice between Redux Thunk and Redux Saga. And Redux Saga is a library that uses generators under the hood, but it also makes you write generator functions as a user of the library. So just at the point of trying to make this decision, I had to figure out this generator thing. And so as I sort of explained, like all this ES6 stuff is landing, and I'm trying to just pick the right tools for this project, and now I have to learn about generators. And this was my moment of this phrase that's been dropped a couple times this conference already, of JavaScript fatigue, right? And I think that people get a little bit like over dramatic about this sometimes. It's like, it's maybe even at this point, like, we're all tired of the medium think pieces, and like this is the reaction that we're having. Like JavaScript fatigue, come on, guys. And that's kind of what I think, because it's fantastic that we're getting these new language features, and like our tool set is expanding. And the fact that we're all complaining about having new stuff to learn is kind of silly sometimes, I think. You know, we have constant let now, and computed property names, and fat arrow functions, and destructuring assignment. And that's just like a brief list of some of my favorite of the new features. Obviously, this screenshot, which I think is from the Babel website, is not even, like, I couldn't even fit it all in. So it's a long list, right? And it's not just JavaScript changing itself. The tools are changing, too. And that's actually, it's deeply interconnected, right? Because some of the tools are actually there to help us write future JavaScript now, like Babel, as we've already, we've seen some discussion of that today. And some of the tools are there to try to make JavaScript into a different kind of language, make development better and more bug-free, and that's things like Flow, right? Changing JavaScript into a statically typed development environment. And some of the tools even are doing a completely different thing, reducing sort of contention and nitpicking in code reviews. And here I'm talking about Prettier, which I've just been shocked at how this was released, I think, January of this year, and it's just gotten wildly popular at this point. So again, like, so what? JavaScript fatigue, maybe not that much of a problem. And that's kind of what I think. Maybe we should just not be doing the medium think pieces. Maybe we should be just kind of saving that as something that you vent about to your therapist. And so let's do that, only let's do it with a computer therapist. So Eliza, some of you may have heard of this before. It's a chatterbot. Some people say chatbots, and some people say chatterbots. I'm not sure why. It was created by Joseph Weizenbaum in the 1960s at MIT AI Lab. And so here we're going to see a little bit of Eliza talking to us. So she's a good therapist. She starts by saying, please tell me what's bothering you. And I tell her JavaScript. And she asks me if I feel strongly about discussing such things. I say, no, not really. And now, apparently, I'm being negative. And I tell her that's not really fair. This is interesting, she says. Please continue. You're projecting your negativity onto me, I accuse her. Do you sometimes wish that you were projecting my negativity onto you? Which is just, wow, that's... And I just say, no, you're crazy. So now I'm now back to being negative. And I tell her she said that already, because she did. And then she, says, we were discussing you, not me. And so I get mad. You're the one projecting. Perhaps you would like to be the one projecting. Eliza's not having a good day. So I say, ha, you wish. And then she kind of cuts to the heart of the matter here, and she says, you're not really talking about me, are you? And we're not, right? We're talking about JavaScript fatigue. Isn't this a great GIF? I love this puppy. All right, so I'm here today to talk about the cure for JavaScript fatigue, except that's a lie. It's my cure for JavaScript fatigue. And it's really simple, and different things work for different people, but I think that this is a pretty useful strategy that might work for other people that aren't just me. And it's just this, like, play with your code. Try to mix a little fun into the learning process if you can, and that applies both if you're doing the learning on your own or if you're teaching other people. So I'm going to take you more through this journey I had learning generators. I started where a lot of us probably start, the MDN page for generators. And then I looked at a bunch of blog posts, because that's basically what was out there. And a lot of them were like, one post in a series about a whole bunch of different ES6 features. And this experience was dry. That would be the word that I would use, like just really dry, really super dry. It was hard work, like getting through this material. And the thing that made it the hardest was that all the examples that were being used, especially in sort of the blog posts, were really abstract. And the syntax for generators, especially if you haven't seen them before in other languages, as I hadn't, it's a bit strange. And the really super abstract examples made it harder to understand because it was so not useful. So now we're going to go through, I think, some better examples of how to use generators. And the end result is going to be a generator interface for the Eliza program. So look forward to that. We'll start with just getting a little bit more precise. There are generator functions and generator objects, which are the result of invoking a generator function. And you'll see a lot of people just saying generator, and they mean the generator function. But we should be a little more precise. So for the syntax, just to refresh you on what a non-arrow function actually looks like, since no one writes them anymore. There are two things. There's a star, and there's the yield keyword, and then there's an off by one error in my slides. So there's the star here. You can put it on the function keyword, or you can put it on the function name. I think some people are already getting like really entrenched in their preferred style, which I think is silly. It doesn't matter where you put it. You can do generator functions as anonymous functions, but I don't think I've seen this once, but you can do it. And now yield. This is really the big one. The first question might be, is it just a fancy return? And the answer is no. It does way more than that. So it does three things. It returns a value. It can accept a value. And it pauses the generator function. And that's the really mind-blowing one, and we're going to appreciate it properly in a bit, but we're going to take these in order. So the first thing that yield does is return a value via the iterator protocol. And you already saw a little bit of that in earlier slides. So if you invoke, or here's the generator function that was on one of the previous examples about the star. It's just yielding a greeting when you pass in a name. If you invoke that, and we store it, a lot of people store it in an it for iterable. It's also a nice short variable name that fits on slides, so I've gone with that as well. So that's our generator object. And then we call next on that, and then here we're going to log the value that comes out of next. So here's what that looks like. So here we're logging it. We're going to log the whole object here. So we see that we get the greeting as the value and a done of false. And if we log the next, call next again and log it, now we get no value and a done of true because we didn't have any more yields in that generator. So that's why there's no value, because the values come out of yield. So second thing, yield accepts a value. But now I am going to back up again and talk a little bit about concurrency in JavaScript. So concurrency is, the very simple definition is doing more than one thing at a time, except that that's actually not a great definition because that implies for a lot of people that you're doing things in parallel. And it doesn't have to be that way, and it isn't that way in JavaScript because JavaScript is still single-threaded. So concurrency, what you really can say is that you're doing thing A and thing B in time periods that overlap. That's the more precise way to say it. And JavaScript has had for a while, a very long time, what I think of as app-level concurrency. So if you think of your web application as a unified whole, including the back end and the front end, then Ajax is the app-level concurrency that's operating between the back end and the front end because you can send off a request and still have the front end be interactive for the user while you're waiting for the request to come back. And then more recently, JavaScript got web workers, and that is obviously in the client, but it's still two separate JavaScript programs. So they are running at the same time, but they don't actually share anything, and you can only, they're restricted to what you explicitly pass between them. So it's not quite the same type of concurrency that generators offer. But it is kind of useful to look at the message passing property of web workers, because that's why I've paused here to get into this, because that's what yield does in generators, is this similar message passing, since it can both return values and accept them. And so, as I said, the concurrency in generators is different from the concurrency of web workers because it's cooperative concurrency, and that's what we're also going to get to, which is how yield pauses the function. So cooperative concurrency is basically handing control back and forth. You're not running two things in parallel, but you're handing control back and forth. So here's the actual code example for yield accepting a value. So we're in a generator function, and we're yielding a greeting again, and we're storing the value that yield is going to accept in this response constant. And if there is a response there, then we're going to yield that response back, and we're also going to yield something else that we'll see in a second here. Like the quiz question here is, what emoji is that code point? So first, we're just going to look at the example where we don't give a value. So here we've invoked, and we have a generator object. And note that this is not where you would pass in the value. The first call of next is not one where you can pass input to a generator, because basically yield opens up a slot for input, and before you've had a yield, you can't pass anything in. So your first next call never, if you put something there, it's not an argument there, it's not going to go anywhere. So when we log this, it's just our normal greeting. Now it's this call that if we leave out anything in that next call, now we're just done, because we didn't put anything in there, and we didn't trigger that if block. So now this is the opposite situation. The first two steps are the same, but now we're going to put hi, and we get that response back, because that's the first thing that the if block did, was yield the response back. And now the second one, we log it, and that's where we find out that that code point is the poo emoji. All right, so the third one now, the fact that yield pauses the generator function. This is truly mind-blowing, because it is the first time that JavaScript has had anything other than a run-to-completion function. So run-to-completion is totally familiar. You have a function that logs 3 things, you call it, and we know exactly what this looks like. All 3 run. But yielding is pausing, and the easiest way to show this to you is also to introduce a pattern that's pretty common in generators, and that's to put a while true loop. This while true loop is not going to lock up your browser, and it looks crazy at first. It may actually be physically difficult to type. It goes against everything that you were told on your first day of programming, like learning flow control, basically. So inside this while true loop, we are just going to yield on every iteration a random number from 1 to 10. And this wouldn't be a good example without proof that this isn't going to lock up your browser. So we have this generator that I just showed you. This is the same one. And then I've just got a little React component that I put together, because that's super easy, and or familiar for me, at least, since this is what I work with all the time. So we're invoking the generator function, and then after the initial render, we're setting up a interval timer to call next on it, on the generator object that we got out, every quarter second. So what we expect to see, if I'm telling you the truth, is that we just get a different number in this state of this component every quarter of a second, and nothing gets locked up. And that is what we see here. And in fact, if you also just want to be super convinced that, oh, it's really hard to see my cursor. There we go. That the while true, or that the yield pauses it, we can change it to a set timeout, and it only runs once. All right, so we've gone through everything yield does now. Returns a value, it can accept a value, and it pauses the generator function. So now this is where we get into the fun stuff. What are generators good for? And it's really good that we've already seen this while true example, because, or, well, I'll get back to that, because that's a really common pattern. But the other thing I'm going to say is that generators are what powers async await under the hood. So it is sort of true that you may not actually have to write raw generators anymore. A lot of the blog posts that I read about generators when I was first reading about them was basically people instructing you how to write what is now async await. So that's, it's coming soon, or you can already use it if you're using Babel and things like that. But there are some use cases that make for generators that are fun and useful outside of just async flow control. And I came upon those because I started thinking about generators as a conversation. I think about especially the type that run with this while true loop. So the generator function, I think about it as this little imaginary friend that's like sitting there in the background with the while true running all the time. And whenever the main program needs something, it can call on that generator function to provide whatever it needs. So this use case is basically chatterbots or chatbots. So we're going to see a simple example and then work that on, kind of use that interface on top of Eliza. So the simple example, we open the conversation by yielding an upside-down smiley, because I think that's a pretty good way to open a conversation. And then we do this while true thing for the sort of ongoing back and forth part of the conversation. And again, I just really like the poo emoji. So this bot just always responds with the poo emoji, and then it stores your input in the message. And when the conversation's done, it waves you off. And it decides to wave you off by just looking for a very simple regular expression there when you say bye. So now this is where we get interactive. So our bot just opened the conversation. So we can say hi there, and it poos at us. And then I can tell it that that's a bit rude. And it's very predictable in how it responds. So I say, is that all you're going to say? And it just poos at us again. So, bye then. And we get waved off. So that's the simple chatbot. And I think I have time to go through a little bit of this part. So just kind of like looking at how this is coded. It's part of these slides, too, if you look at it on GitHub. Thinking about what a conversation is really, in this case, thinking about what data structure represents a conversation. And for this simple example, that's basically just an array. An array is naturally ordered, and so is a conversation. And all we got to do to know who's saying what is, put a little ID on there for who says what. And basically, participation in the conversation is just pushing to the array. So what this looks like in a web app is that for the user input, the live user, on the submit handler for a little text form entry, we push to the array the form value. And then in the same handler, we can just get the, call on that generator that's waiting in the background to respond to us and pass it in our input and then get its response. So now we're ready to take that simple interface and put it on top of Eliza. So I'm using the JavaScript port of Eliza. There's many, or I don't even know if port is the right word or implementation. There's many implementations of Eliza. Wikipedia, as you might imagine, is very informative on this topic. This is the link for the JavaScript implementation, and I'm not the first one to repurpose it. I think there's at least half a dozen packages on NPM that use it in some fashion. So I'm going to read to you a few things from Weizenbaum's 1966 paper about Eliza, because honestly, I couldn't say it any better. So describing sort of what Eliza is, he starts, at this writing, the only serious Eliza scripts which exist are some which cause Eliza to respond roughly as would certain psychotherapists, Rogerians. And that's referring to somebody named Carl Rogers, who basically invented person-centered therapy, which has a very specific formula that turns a lot of things back onto the patient, which is crucial, as you'll see. And Eliza performs best when its human correspondent is initially instructed to talk to it via the typewriter, of course, just as one would to a psychiatrist. I put that little exclamation point in there because typewriter, how quaint. This mode of conversation was chosen because the psychiatric interview is one of the few examples of categorized dyadic natural language communication in which one of the participating pair is free to assume the pose of knowing almost nothing of the real world. So really, categorized dyadic natural language communication? I mean, jargon much? This just means a type of conversation between two people. So I fixed it. And then this is my favorite part. If, for example, one were to tell a psychiatrist, I went for a long boat ride, and he responded, tell me about boats, one would not assume that he knew nothing about boats, but that he had some purpose in so directing the subsequent conversation. So that's what's really key here, right? This is how the therapist just turns everything back to the patient, and this pattern of communication allows you to code a very unsophisticated chatbot that still seems real. So this is what the algorithm actually looks like, summarized. There's 3 stages. There's a decompose, transform, and a recompose. So to take an example, if the input is, it seems that you hate me, the decomposition happens based on keywords. And the keywords are things like, in this example, they would be you and me. They're like very common words that they can code into the program. So you break it up at every point where you run into a keyword. So you get these 4 chunks in this case. And then the transform step does things like reverse pronouns. So you becomes I and me becomes you, because now we're creating the response. So we have to reverse the pronouns. And then the recomposition, basically, there'll be a bunch of different recomposition rules for every template involving keywords. And so it just will replace sections of that template with something else. So in this case, it seems that gets replaced by what makes you think, and then a question mark gets added on the end, and then you get the therapist response, what makes you think that I hate you? So this is an example of a rule set from the actual JavaScript implementation. So this is one of the matching templates. So the stars here are indicating slots that are wildcard slots, right? And the I and the U are the keywords. So everything that matches this template will end up selecting from one of these recomposition rules. And Eliza is rather sophisticated in that the program actually tracks how often each of these rules are used so that it doesn't keep reusing the same ones. And so then the numbers here are where the part, here it would be what's between I and you will be in the input will be replaced in each of these templates. I thought the first one was really inappropriate, which is why I picked this example. So now here's what the generator version of interface for Eliza looks like. So the JavaScript implementation is done as a constructor, and it's designed so that you can create multiple instances of Eliza, because one of the things that a lot of people like doing is making Elizas talk to each other. I simplified that, so if you want to do that, that'll have to be an exercise for your own time, your own playtime. So I simplified it, and I took out some of that and just made this you call the function, and it returns this generator function that's closing over some of these internal methods and state. So it's a little bit actually simpler than the other Chatterbot example we looked at. We start with getting the initial opener from Eliza by telling her that there's null input and that we're starting the conversation, and then store the response in this input variable. And this is simpler because we don't even have to do the while true, because the rest of this Eliza program is tracking this piece of state, which is whether or not your input indicated that you're ready to quit. So we just do while you're not quitting. And then every single time, we just take the input from either the beginning or from the last iteration of the while loop. Remember, that's how the yield works. It takes the input. This input will be your response to whatever's yielded here. So this one is always the one from the previous iteration. So that works quite nicely and allows us to just keep it this simple, and Eliza still gets to close the conversation whenever she detects that you're done. So this is the part that is super fun, because now we're just going to close by chatting live with Eliza. So I'm going to tell her that last night I dreamed that I died. What does that dream suggest to you? I'm gonna hedge. That's quite interesting. I don't know where to go from there. I'll just write that. Don't you really know where to go from there? All right. So anyway, you kind of get how this goes, and so I can't get out of those slides. So I hope you enjoyed this, and again, the slides are online, and they're also based on a GitHub repo, so you can find that, I'm sure, by looking me up. Thanks. I'll leave that there.
I feel like we need one of those therapist couches now. To,
yeah, it is.
Tell me about
fair.
how you feel about your talk.
Yeah.
That was great. Thank you. I want to read some comments from the audience because they had nice things to say. Let me make sure Twitter reloads. I love the solution proposed for solving JavaScript fatigue, playing with your code instead of playing with your food. I really like that too. It's like a very productive response instead of just like, no, it's not, or I don't know, arguing more about it, writing more about it on think pieces, or writing more think pieces about it. One thing that I thought when you were talking about the cooperation between, like, you're yielding, you're waiting for a response to come back from the generator, it kind of sounds like event handling in a way, right? You write your event handler, and then your code is sitting there waiting for stuff to come in. I don't think I have a question there. It was just a thought.
It is similar. I mean, I think one of the weird things about generators is there's definitely ways to do almost, I mean, obviously you can code chatbots on Eliza and everything without them. It's sort of a question of what's elegant. And if you start to look into how you use generators to manage async flow, and that basically results in async await, you'll see how it's super elegant. Or results in something really elegant, like the async await syntax, basically.
Sure.
So I think it comes down to that.
Yeah, it kind of makes a little more sense. I've looked at the compiled or transpiled results of generator code or async await code, and it has all these horribly nested state or switch statements and cases and stuff, and it makes a lot more sense why you need that after this talk, because you need to keep track of like what state the generator's in. And yeah, so that was really helpful for me to understand that more. I liked the first bot that you demoed that responds to everything with poo emojis and then patronizing waves goodbye. Is it fair to call that a Twitter simulator?
Probably. Yeah, probably.
And then one other thing, when you were interacting with Eliza at the end, it responded, then you didn't. The response didn't really lend to a reply. You were like, I don't know where to go from here. It feels like the interaction you would want with the bot is the bot would then prompt you with something else. Is there a way that you could do that with generators? I mean, you can only yield in response to you calling into it, though, right? So you'd have to have some timeout on your side. You couldn't just make the generator like magically unpause itself, or?
Yeah, I think that'd be more about improving on the Eliza algorithm, so making sure that most of the responses in there don't leave the conversation dead. Since I do have a linguistics background, like looking at that and how horribly simplistic it is, it's sort of tempting to try to make a better Eliza, but that's I also know how hard that would be, so I don't think I'll do that. But.
Sure. Someone else from the audience can do it then. Your next great startup idea. Awesome. Well, generators make more sense to me now. That was great. Thank you so much.
Yeah, thanks. Thank you.